Okay, now we want to use some square cross sections. Now you'll notice we have the y-axis, we have the x-axis, and now we have the z-axis coming through here. So we have 3 dimensions. Now, if I want to make a square cross section, that would be a nice pretty square. And let's give it some thickness here. There's a square with some thickness. And up here I would have a square, and that square has some thickness. And it's going to cross here, so that this backside is f of x tall. But if this is a square cross section, that means this is also f of x wide. So in this case, I have a little chunk, and that chunk is f of x tall by f of x wide, and there's a thickness to it. Now, the nice thing is with calculus, our goal is to get infinitely small thickness, but the way we do that, of course, is taking the limit of dx as it approaches 0. So what you have is you have this volume, like a stack of pizza boxes. So we're taking this area here, flopping it down, and making sure that we can find all of these little rectangles all the way out of here. So we have all these rectangles that we have to add up. All right, so with that, we're not going to use pi r squared anymore, because that's for a circle. We want a square. So that's easy enough. We can just sum up side times side according to dx. So in this case, it's going to be f of x times f of x times dx. And from -1 to 3. So we can simply fix this to say from -1 to 3, f of x, the quantity squared, times dx. Now, if we're dealing with a triangular cross section, so that was f. If we move to g, we want the same thing, but in this case, we want triangular cross sections. And so to get triangular cross sections is fairly easy because there's some key words here that we have. We have right isosceles, so this side and this side are the same, with a right angle at the bottom. So if I take the area of a right triangle, all it is base times height times 1/2. So area equals 1/2 base times height. But if they are isosceles, area equals base times 1/2, or area equals, in our case, 1/2 side squared. So you have exactly the same format you had for squares, but you're going to have -1 to 3 f of x squared, and with a 1/2 out front. Now, folks, doesn't it make sense that you're going to have half the volume if each cross section is exactly half as big? So with that, you should be able to finish up everything in this section.